All right. Hello, everyone. Right. Thanks for coming. I'm Chris Fonseka, as it says on screen. I'm an iOS engineer at Peak. And today I'm going to talk about designing user experiences and features that make your apps feel personal to every user. The way we're going to do this is I'll talk about what it means to be personal, how we design for our users at Peak, and then move on to how we could potentially do it better. And regarding that last point, you may have noticed I spoiled the ending in the title, but it's 2018, and putting that in there is a great way to grab your attention. So to begin with, I'm going to be using Peak as a case study throughout the presentation, so a good place to start is just to quickly explain who we actually are, like 3 slides of shameless self-promotion, I'm sorry. Peak is a wellness app. In it are 42 brain training games, each designed to focus on some level of your mental skill set, so memory, coordination, problem solving, etc. Each game is about 1 or 2 minutes long. And so the idea is you play a couple of games every day, we track your progress, give you really helpful analytics, and help guide you to a kind of holistic improvement. Peak is a free app where you can play 4 games a day, or a few more if you want to watch a few ads. And underneath all of that is a subscription model where you unlock the full catalog of games, and you can play as much as you want, anytime, anywhere, etc. So what does it mean to be personal? At its core, designing personalized features and interfaces is all about understanding your users. So I have 2 screens here. It's a billing screen. The rhetorical question I have for all of you is, which of the 2 do you prefer? Now, everyone is going to have an answer to that. You're going to be drawn one way or the other. Why is completely up to you and often very difficult to answer. And if we were a giant kind of overbearing product team, we could spend a couple of hours debating which of these 2 to push out to our customers to maximize revenue. But the fact is, while our opinions are valid, it's the opinions of our users that drive the success of our app. And they all come from vastly different backgrounds, cultures, sometimes languages, different ideals to you. And so the buy button that you're going to press might not necessarily be the buy button they press. Understanding your users is all about validating the choices that they'll make given a set of options. And the important thing is removing your own personal biases from those design decisions and figuring out the best way to do that. So at Peak, we do that using A/B testing. Now, who uses A/B testing? Is everyone? Oh, fantastic. There are a few people without their hands up, so just to make sure we're on the same page, we have our 2 designs, or typically it will be, one is what we do now and one is a nice new design, so we have a control. We segment our users into 2 groups. Now this is going to be 2, smallish groups, kind of a minuscule percentage of your user base, usually in like a lower risk market like Australia or Canada. That's the way it is, I'm sorry. And you will push one of the 2 designs exclusively to each group. You'll then collect a meaningful amount of data, analyze the results, make very attractive graphs, and if one of them pushes the needle in the right direction, you have your winning design, and that's the one that you ship to the rest of the world. The great thing about A/B testing is that all your design decisions are based on the way your users actually behave, rather than just kind of educated guesswork. It also adds a layer of protection before you push things out to millions of users. If you have a feature that makes people want to flip the table, rate you 1 star, you can kill it early. It only affects a small amount of your users, and it never has to see the light of day. Having an A/B testing framework also kind of encourages tiny experiments. So making little changes, little color changes, finding all the small differences that can make massive differences in future. The downsides of A/B testing is, firstly, it slows down your development. We have hundreds of thousands of daily active users, and it still takes us about a month or 2 to get statistically significant amounts of data. So that's just something you have to factor into your feature lifecycle. It could be quite a while before everyone sees it. And the second, more kind of problematic issue is sampling. You can sample. Australia and Canada is usually picked because they're relatively small markets that are English-speaking, that share a lot of ideals with bigger places like the US and the UK. But the way they think isn't necessarily the way the rest of the world thinks. A good example is Starbucks, really popular in a bunch of places, but nowhere to be seen in Australia, or at least there's only 1 or 2. Why that is, I don't know. But the idea is the results you see in your A/B tests might not be a good reflection of what you'll see when you push it out to everyone else. And the bigger problem is when you sample people, it pushes you away from the whole theme of this presentation, which is about designing personal apps. You take any one person at random from that sample, and you can't say they think the same way that everyone else in that group thinks. So there's definitely ways that we can do it better. And surprise, surprise, the way we do it better is machine learning. So the state of machine learning right now is you can run an algorithm on an individual user's device, and it can make decisions based on just the way they use your app. So there's no need to sample. You can focus on one user, one device, and make decisions tailor-made for them. Now, there are a bunch of ways to integrate machine learning into user interface design, and today I'm just going to talk about 3. Firstly, adaptive user interfaces. This is where interfaces change in reaction to the way your user actually uses the app. And there's a couple of ways that you can apply that. Firstly, simplifying common actions. So if you find from the data you've gathered that there's one particular flow that's constantly being used, one feature that is used a lot, you can move that feature into more prominent areas of your app. So it could be the first screen they see when they open the app. For us, we have this nice little home carousel on the homepage, which just has loads of shortcuts. So taking the things that they love using and moving it into a more prominent area, making everything really nice and snappy. In that same vein, you can also encourage navigation. So if you've implemented a new feature and you really want everyone to use it, or for us, if we want to encourage users to play games that they're kind of neglecting, we can move that into the prominent areas of the app and try and nudge them very subtly in that direction. And also, you can remove things. So if there are features that aren't being used that often, that don't really contribute to the overall experience of your app, remove them, bury them in sub-menus, or just clean up your design so everything's nice and minimal. Finally, we can use machine learning to reduce complexity. Now, with a lot of advanced apps, things like, imagine when you open Photoshop up for the first time. There's buttons everywhere, there's lots of menus and screens and just things that make the app feel rather overwhelming. This is pretty common, and the usual way to deal with stuff like that is to have some kind of gentle onboarding experience, whether it's slowly showing more and more panels or having little pop-ups that point towards buttons and say, try this and see what happens. That's a pretty common practice, but using machine learning, you can get a much better sense of how your users are how hard your users are finding the experience of using your app. So figuring out how long it takes them to do common tasks or things that you would expect them to be familiar with, how difficult are they finding it? Using this complexity score, you can adjust the speed of your onboarding process. So at all points, they feel comfortable, they feel like it's not too slow, it's not too fast, they're getting a better sense of your app at the right pace. It could even allow you to create completely custom experiences based on things like their age group. Now for us, different age groups want different levels of control in peak. They want to see more or less things. And so using this model, you could absolutely do that and completely hide certain features from certain users. And in peak, there is a very specific use for reducing complexity, and that's the games themselves. Now, right now, if you start playing a game in peak, you achieve a certain score or you unlock a set of achievements, and we bump you up to another level. That makes everything a little bit more challenging, maybe adds a few things to the games. But a really common problem is you reach a level that is a bit too complex, a bit too challenging for you. And at that point, it's a point of friction. You just don't have an enjoyable experience anymore. And what typically happens is you abandon that game. You never play it again. By monitoring a user's progress in a particular game session, seeing how complex they're finding everything, we can ensure that they're always at a level where they're in that nice channel of flow. Nothing is too challenging that they get anxious. Nothing's too easy that they get bored. And we can even pair that with stuff like time of day. If a user performs better in the morning or in the evening, we can completely customize it so they always feel the appropriate level of challenge. The second example is rather boringly called customer lifetime value. This is something you can actually do right now in your apps. It's a service that Google offer. And to put it simply, it's all about when to show this screen. Now, if you want your users to click buy, click subscribe, make an in-app purchase, bombarding them with billing screens is not the right approach. Using Google's machine learning system, you can figure out when a user is most likely to click buy and only show this screen at those moments. But CLV goes a little bit further than that. Some users just don't want to put money into your app. They are never going to buy no matter how often you show it or how infrequently you show it. But they might click buy if you offer them a 40, 50, 60% discount. CLV can figure out when's the best time to show a specific screen and also what's the best discount to present to a given user. You know, big enough that they will click buy, but small enough that you're not actually losing revenue. The final example I have is help guides. Clippy's back. When a user first downloads an app, they start using it, there's going to be things that they don't find particularly intuitive. There's going to be stuff that they need help with. And so what they'll do is they'll use your app, they'll want to find a feature, or they'll have some trouble, and they'll go to the help section of your app and try and look it up. With that data, you can do two very cool things. Firstly, you can suggest things in the help section of your app. And secondly, you can feed all of that data back to your designers, back to your developers, and figure out exactly where the pain points in your app are. And in a future release, you eliminate them. So it's really valuable data to gather that helps you understand more about how individual users are thinking. Another particularly relevant example for Peak is that once you play a game, we have this thing called Coach, which is the second speech bubble. Based on your progress in that game, we can suggest playing the game again if you're about to unlock an achievement, or maybe you've done well in a particular category, so we might say, hey, why not try this game? Just kind of broaden the different parts of the brain that they're working out. Tracking these pain points, tracking this complexity, allows us to make that far more intelligent, so we know exactly when to try and push users out their comfort zone and really progress them along the app. Now, there are limitations to machine learning in this application. Firstly, users really don't like change. If Facebook decide to change an icon or increase the size or change the angle a little bit, people go mad. And that's because we're humans and we get used to things. We get used to layouts even if they are a little bit flawed. There isn't really a way to solve that human condition, but tracking the way users react to changes is something that you can integrate into your machine learning model. And through that, you can identify who you shouldn't change anything for. And secondly, machine learning needs concrete data. So machine learning essentially needs numbers, it needs ones and zeros, it needs parameters that it can optimize. What you can't do is the kind of stuff you can do with A/B testing, where you can have a dramatically different design or a completely new feature and just see how they react based on that kind of giant black box. So the key to providing personalized experiences is understanding the tools you have and knowing when which one is appropriate. So just to recap, we talked about the importance of understanding your users. We talked about A/B testing and how Peak use it to understand all of our users, and machine learning and using it to understand individual users. And hopefully, with the stuff I've talked about, you can use these tools, figure out when it's appropriate, and use them to make every single download feel personal. Before I go, here's the obligatory, hi, Peak is great and we're hiring, well, hey. It's a nice place to work. We just got a new office which is just next to the Shard, so everything's really slick now. Yeah, and that's it. I've been Chris Fonseka. You can follow me there, and personalized apps using machine learning. Thank you. Cool. Do you have any questions? Okay, cool. In front.
So where do you have all this where the machine learning happen? On the backend or on the device?
The question is, where does the machine learning happen? Ideally, it would happen on the client. There's no reason it can't happen on the client, but because that tends to be the way machine learning is going these days, and this isn't particularly complicated. But if you have a giant application, the data can, increase quite quickly, and so you could move to the back end. But our intention is to run it on the client. Sorry, yep, behind you.
So how there was a slide where you said tracking the UI flow.
Mm-hmm.
How do you track that? And also with this GDPR, etc., how do you anonymize all of that you're not individually tracking the users and stuff like
Okay, so the question is, how do you track user flow through the app? And lovely question about GDPR. In terms of how you track the flow, it's pretty common with a lot of analytics tools. You essentially track the button taps, and whenever a screen is presented, that data goes back to your analytics engine. And so you can kind of build a map of how users are doing things, and also sum them together where you have like 50% of your users go here. In terms of GDPR, the key is all the data has to be anonymized. So yes, tracking for if you pair that usage data with this person, this email address, this date of birth, then you're in violation. But as long as everything gets essentially paired with a random identifier and you're just collecting data and seeing sums, it's generally okay. It's worth noting that all the tracking stuff is not new ground. This happens a lot with a lot of big apps. Cool. There was a guy behind you? Yep.
Yeah, can you make examples of where you use machine learning and like what KPIs you use for showing one thing or another?
Okay.
One term or another? Yeah.
Okay, so the question was, can I kind of show examples of where we're actually using it?
Yeah.
Okay, it's a great question, and I would also like to know the answer to that. Right now in Peak, we're thinking about machine learning and the way we can integrate it into our apps and some of the cool things we can do in terms of our feature set, but we're still in the exploratory phase. We haven't actually implemented the systems yet. So if you're willing to invite me back in a few months, I can tell you, but yeah, that's it. Yeah, and fine.
So, what kind of framework do you use for machine learning? Is it TensorFlow or is it Japanese or ML or AML?
Okay, so yeah, I can't answer your question, I'm afraid. The mic doesn't want me to. I just pushed in. It's okay. Yes, excellent. Right. Sorry. So the question is, what kind of framework am I using? Whether it's TensorFlow or Apple's native stuff. Again, we haven't actually implemented this yet. We're still exploring our options. I think knowing our team, it's probably going to be native because we're a native iOS team and we really like Apple. But if TensorFlow can offer something more advanced, then we'll probably go down that route. But if you have knowledge about that, I'm more than happy to hear you afterwards. Cool. Oh, wow. You.
So you said you're still in the kind of experimentation phase.
Mm-hmm.
Do you have any kind of idea of the amount of development time, say just the simple like getting people to buy more often, how much development time that would take?
So the question is, how much development time will all of this take, specifically referencing the getting people to buy more often. Now that example is kind of an exception because that's Google services that we can actually use. They have this whole kind of churn flow thing. You can look up customer lifetime value later and kind of see what they do. So that I actually don't think would take as long as the rest of it, which is more implementing, creating the models ourselves and figuring out the best way to implement them. In terms of like man hours, I have no idea. Sorry. Oh.
Someone that can answer this one.
Yeah, sure.
Basically, for example, just for give a small example, if the user will churn or will not churn, and the user is very likely to pay or not likely to pay, like some of the models already, you can use Google Firebase, you can use AWS services, and basically, if you already have analytics in place, you can decide which events are important in the flow. And then you can just have one more provider. They send the same event to different endpoint, and that's it. Basically, we did half a day to get several of those models.
Cool. And sorry, last question.
Have you considered to use genetic algorithms to this kind of decision sort of the game other than machine learning?
Sorry, can you repeat the last bit?
Have you considered
Genetic algorithms, yeah.
to use genetic algorithms as one option to use machine learning in order to sort the different games by different variables that you can parameterize?
So the question is, have you considered genetic algorithms to do things like sorting games? The answer is no, but I'm really keen to talk to you about it afterwards. Yeah, cool. Thank you all very much.
Thank you.